Hey guys, I'm going to give you a little video on something in science we call significant figures. Significant figures is about how many of the numbers in a value are significant. In other words, they're giving us measured information about the whatever value we're trying to determine. It's really important in science. So if you've ever taken and multiplied or divided a number on a calculator and now your whole screen's full of numbers, well, you can't keep all those numbers. So in math class, maybe you said, okay, just round off to the tens place or the hundreds place or wherever. We have real specific rules because whenever we have some kind of measurement that's taken, the numbers that we have reported are telling us something about how accurately we actually know those numbers. So, and there's also going to be a little video on precision versus accuracy. Those are some terms that get confused a lot as well. We're looking for both. Okay, so if we've got a real precise instrument, we also want it to measure quite accurately. All right, so what exactly are significant figures? Well, significant figures are those numbers that the measuring device actually determined for us. So we've got a lot of different ways of doing that. So for example, here I have a graduated cylinder. So let's say I measure out the graduated cylinder and it's filled to right about there. Now you can't tell what that number is, but let's say it's 50 milliliters. Okay, that's not a very good job of measuring, so what we're going to find out is they actually go by individual milliliters. Now where you measure a liquid is in the bottom of the meniscus. You're supposed to estimate in between the smallest division of the scale. And I said, hey, take a better look at that. And you find out it's like, oh, it's just past the 50, but not quite to the 51 mark. So what we should have said is, okay, what we should have said is that value is 50.2, and the last number being an estimate, milliliters of water. All right, so how many of those numbers are significant? Well, that's significant, that's significant, that's significant. The measuring device measured to some degree of accuracy those three numbers. So what we would say is this has three significant figures. Okay? So some of the numbers are really easy to tell. When you see a value, if it's an integer, that's a significant figure. Something showed up, that's some part of our measurement, that's where we have it right there. The numbers that give us difficulty are the zeros. Because zeros, sometimes we need them because the number is really big or really small. So they'll tell us like the magnitude of the number, let's say. Other zeros are actually significant because it was right on the zero mark. It was a number that was actually measured. So this takes a little bit of time to get used to this, but it's usually not that hard. So I'm going to show you some numbers and we're going to determine, okay, how many significant figures or measured values does that number actually have? Okay, so I got some numbers over there. Let's erase this so it's not in our way. Okay. You have 59.01. How many significant figures does that actually have? 1, 2, 3, 4. Now that's a zero right there, but it's sandwiched into between significant values. There's no way the scale measured out to the hundreds place if it doesn't also measure in the tens place. So we would say that that has 4 significant figures. All right, let's jump down to this one, the milliliter. That's a pretty easy one too. So I had 1.25 milliliters. I got a real accurate thing, so I'd probably have a pipette or a burette. You guys are going to use that stuff to measure that out. That actually has 3 significant figures. Okay, this is where it gets a little bit tricky. So you've got a really good timing device. Say you got somebody that's running the 100 meter and they finish in 11.20 seconds. How many sig figs does that actually have? And it's like, well, 3, right? So it's just 11.2. That's the 3 sig figs. Nope, that would be wrong. This number out here, we wouldn't write a 0 to the right of the decimal like that unless the measuring device actually went out that far. So this will measure to the hundredth of a second. So it wasn't 11.21 or 22 or 11.19. It was exactly 11.20. So we'd say this number has 4 significant figures. Okay, here's somebody that did a measurement for me, and I said, okay, go measure out this amount of water. The user graduated center and said, hey, it's 8 milliliters. Well, that only has 1 significant figure. And in an advanced chemistry class, that's not very good. You have a very low accuracy number. I'll say, hey, go measure that a little bit more carefully. And they take a look at it and it says, but Mr. Kohler, it's exactly on the 8. And it's like, okay, well, we're supposed to estimate if it's exactly on the line, then you need to say 8.0, okay? You can measure out there into the tens place, and it's accepted that it's going to be an estimated value, so this would actually have 2 significant figures, okay? So that's a little thing on how significant figures work. You have to identify it. Now here's one that's kind of a pain in the butt. Okay, so let's say we've got to measure a big distance and it's exactly 1 kilometer. It's supposed to be a decimal point there. Now you can maybe see it a little more. Okay, how many significant digits does it have? Well, it's 3. Okay, the 1's obviously significant. This is the final 0 to the right of the decimal, so we know it goes out that far. Well, if it goes out to the hundredths place, it obviously is measuring in this place. And so we measure this value to exactly 3 sig figs. Now let's convert that over into meters. If I converted that into meters, there is 1,000 meters in a kilometer, so this number then becomes 100,000. That's a little bit problematic, because how many sig figs does it have? Well, okay, we know that from the original measurement was significant. We also know that and that also are too. These zeros aren't significant. Your measuring device didn't go out that far. So that's really problematic for us because we got all these zeros. Well, we need them because that's the magnitude of the number, but you can't change the accuracy or measurement just by changing units. So there's a trick. What is the trick we use for this? We use what's called scientific notation. So instead of writing it this way, I'm going to go 1, 2, 3, 4, 5. 10 to the 5th means 100,000. We write the number that way. Now this is still 100,000. 1.00 times 10 to the 5th power, which is multiplied by 100,000, is still 100,000. Well, the difference is right here, now I know anything that I write up here in front of this thing, which just tells me how big or how small the number is significant. So I know my original measurement had 3 significant figures. So those are some of the little things you'll run into. Most of the time determining sig figs isn't that difficult, but once in a while when we run into something like this, it's a little problematic. Okay, so there's going to be a link in here that takes you to some problems right there, and I want you to do the part where you're just identifying how many sig figs something has. You don't have to do anything else yet.